Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Good afternoon. How is everyone? Studying well for the papers, enjoying your learning, isn't it? Okay, now we have been revising different chapters, and today is the chapter that we are going to revise is chapter number 4, software. I hope that we all know what is software. Yes, exactly. Software is program. Simple computer program is given the name software. What are the two types of software? We all know it's system software and application software. So we'll start from the basic terminology that is basically software and the types. Here you can see, just to make you understand the concept of application and system software, you can see this is the hardware. And all the hardware components are actually communicating with the system software. And if system software is there, only then application software like spreadsheet, your games, your browser, your databases, word processors, and other software can work. So you can see system software is the basic program that is needed. And if system software is not there, corrupted, or has developed some problems, then you cannot work on any application. And remember, the applications are able to access the hardware via passing through the system software. Fine. So now this diagram, this figure, I recommend you that you go through this figure and remember it, that basically the two categories, application software and system software, a number of application software, as you can see here, spreadsheet and word processors and databases, browsers, they all are mentioned here. And system software is actually composed of three main components: operating system, which is shortened as OS. Sometimes we do use it as OS for it. Utility programs or utilities in short. And the third one is device drivers. Before we proceed to the actual discussion, let's very quickly know what are the general features of system and application software. What is a system software doing? It is a set of programs that are needed to control and manage the operation of the computer hardware. So if you talk about all the components, all the hardware components are actually under the control of system software. It is also providing a platform to make this other software run. If system software is missing, then the other applications can never function. It's required to allow hardware and software to run without problems. Like definitely they are able to have everything done properly because of the presence of your system software. And one more important thing is it provides HCI, which we will discuss inshallah later. It is also there to control the allocation and use of hardware resources. Which hardware component is going to be used by which application, etc., is all handled by the system software. Now, moving on to the application software, it is used to perform different applications, different tasks. Every single application is performing its own predefined task. It is allowing a user to perform specific tasks using the computer's resources. It can be a single program, like you can see Notepad, or maybe a suite of programs like MS Office. User can execute the software as and when they require. And these are very simple features which are mentioned, and I hope that it's very much clear to every one of us. Now let's move on to the examples and how the questions can come, although it hasn't come yet. But what I am anticipating is maybe they can give you a list of different applications on one side and the uses on the other side, or maybe their definitions on the other side, and you are asked to match. And for this, it's very simple. You need to know what is a word processor. It's used to manipulate text document. Now, very correctly quoted by Ali that with word processor, the thing that comes to our mind is MS Word. But remember, we are not allowed to use the brand name. So for this, I request you to restrict yourself to the main term like word processor, spreadsheet, and databases, rather than using MS Word, MS Excel, or MS Access. This is what my sincere advice to you all is. Moving on to what is it, how do we use word processor? We use it by entering the different, can say, different text values through our keyboard. And definitely it is meant to create, edit, save, and manipulate your text. It is also there to perform copy and paste. It's most important thing of a word processor is it is there to perform, it has a spell checker and has thesaurus also. It is also allowing me to import or insert different images in a proper format. Translation into a foreign language is also one of the features which is given to me by a word processor. So very simple basic features of word processors are being discussed here. They're not asking us to know the in-depth study, or there are other features also. If you know them, you can write them down. That's perfectly okay. But you need to know the basic features which are provided by a word processor. Fine. Now moving on to spreadsheet. What is it actually? It's a combination of rows and columns. And these rows and columns are actually given a certain reference, and they are referenced by that cell reference. Fine. And you can see what are the basic features of a word processor. They are mainly used for performing calculations. Like we use some formulae for performing the calculations. The very important thing about a spreadsheet is it is allowing me to produce graphs. And another one that we are very much using in our practical life is the ability to do modeling and what if analysis. What may happen if certain things are changed or certain values are changed. Thirdly, it's databases. Just for reference, you can note down OS access. You may have yes, exactly. We have talked about it a little bit in our database topic. Thank you very much. So you may have studied that there also. So what is it meant to do? It's there to organize, manipulate, and analyze your text. And here the concept of fields and records and the table is definitely going to be there. Basic features of database include it is able to carry out queries on the databases, and it is able to produce a report also. We have different forms through which different reports are generated. Also, it is able to add, delete, and modify data in a table. Along with that, what else we need to know is the control and measuring software. By the way, again, controlling and measuring, we already are aware of with respect to our controlling and monitoring applications. So the same thing, it's there to measure physical quantities in the real world, such as temperatures. It is there to control applications such as a chemical process by comparing sensor values with the stored data and sending out signals to allow the different processes to be either altered or like maybe bringing an alarm in case of a monitoring application, or it can be if something is going wrong outside the values, acceptable values, preset values, then it is going to take some corrective action as is present in your controlling applications. So if you talk about application software that is controlling and measuring, it's something similar to what we have studied, and it's just the use of the proper application. Apps, a very commonly used word that we hear. It's simply a short of for applications. And it's normally referred to software which is running on mobile phones, basically. And these apps or software applications are downloaded from an app store, and they are ranging from different small games to maybe some sophisticated software also that are meant for various purposes. What are we normally using the apps for? Video and music streaming. We're using it for GPS. We're also using it for camera facility, like storing, manipulating, and taking photographs also. So different applications are available, which we are using quite often in our tablets or mobile phones. Photo editing software, like what do we use, which different applications we use is what are their purposes, what do they do, like they are able to help in changing the brightness, changing the contrast, or alter the colors, saturation, or remove the red eye. They're also allowing for complex manipulation of your photos, like they are there to change the features of a face. They're able to combine the photographs. They're able to alter the images to give interesting effects. And a lot of other applications, facilities are also provided by your photo editing software. Actually, this photo editing is also allowing the photographer to remove unwanted items. Maybe you want to remove certain parts of the photograph, then all is possible with this photo editing software. Similarly, we have video editing. It's exactly, we are habitual of using different video editing software, mashallah. So you are aware of them. So what is it actually? What can I do? Basically, it's video editing software has the ability to manipulate videos to produce a new video, and it also enables the addition of titles, color correction, and altering or adding sound to the original video also. Uh, what is included as a part of the video editing software? It's there to rearrange, add, and or remove sections of the video clip. You can apply different color corrections, filters are applied through that also. Yes, this is what you already know, mashallah. And then creating transitions between clips in a footage also. This all is possible. We are using different applications and we are aware of them. So this is what is something that you already know. Similarly, graphics manipulation software also has some features which we are using, like it's allowing the bitmap and vector images to be changed. And I hope that you know what are bitmap images. They're made up of pixels and they result in pixelation once you are zooming the picture. On the contrary, if I talk about vector graphics, they are operated in a different fashion and they are not pixelated because they are working a little bit differently. They are able to manipulate lines. Actually, the picture that is saved as a vector graphics is increased or decreased proportionately, and that is why it does not suffer from pixelation. So again, not a part of the syllabus at all, but still, if you know that's benefiting, that's definitely going to benefit your learning. Now, I hope that there's no confusion regarding application software. So now let's move on to system software. Now, the system software that is mentioned, by the way, device drivers, you already are aware of. We have studied it in chapter number 2. But still, a very quick recap. In examples of typical system software, the first one that I'm referring to at the moment is device driver because we already have studied it. Simple applications, software that is needed to make the devices work. We do have device drivers for every single hardware component that we buy. And in case of USB digital revision, in case of USB port being used, the device drivers are automatically installed. We don't have to actually look for the appropriate device drivers because this is going to be installed automatically in case you are using the USB port. And these simple programs that are needed to make the devices work. Like we do have printer drivers, we do have drivers for each and every hardware component that we buy. Now, moving to compilers and linkers. Simple, what is compiler? It's basically a translator. And this translator is needed to translate a program that is written in high-level language to machine code. And this machine code is understood by the computer. And remember, and basically the program that you type is the source code, and whatever is understood by the computer is the object code. And once a program is compiled, the machine code can be used again and again to perform the same task. This is a very important thing that we need to know, that once you have compiled the program, the compiled code or the object code can run without the need of your source code at all. So again, which languages are needing the, like which are the high level languages which are needing the compilers? You can see Java, we've heard about it. C++ is also in the same category that it is needing the compilers. And we do have other interpreters also. These are handled a little bit, these are handling the conversion, the translation a little bit differently, but these both are meant to perform the translation of the source code to object code. So I hope that that is making sense to all of us. No problem to understand the working of compilers at all. Now, linkers. This is a new term for you people. A linker or link editor, it's a program that takes one or more object file produced by a compiler and combines them into a single program which can be run on a computer. Like you can see, maybe object files are 3 in number. So what will linker do is it will take all the 3 object files together. Now, okay, I'm just giving you an example. There can be other number of object files also. If 3 object files are created, what will linker do is it will take all the 3 object files and will form one complete object file out of these 3, and that will be there to run separately. You can see like some programming languages are allowing the use of linkers also. Like maybe you can see that I'm using different modules. I'm working on different parts of the program. I'm working on different pieces of the program, and these pieces of code are called modules. And the module approach or modular approach is needed just to make the task of programming a little easier, because different people are working on different different modules, and then it becomes more manageable. So once they have designed their own modules, we are going to combine them into one piece, and that one file, I'm just using one piece just to make you comprehend, that one file is going to be your running file, and this is the job that is performed by the linker. Now moving on to operating system, as you can see, what is it meant for? It's essentially the software running on the background of the computer. So now remember, operating system, as I said in the beginning, OS, this is one of the most important programs that are needed to make the system work efficiently. Without OS, most computers would be very user unfriendly. I mean, you need some sort of operating system to work, and the majority of users would find it almost impossible to work. Believe in me, definitely without operating system, the computer is nothing. So that is what is going to be needed to make the systems function properly. They are there to allow input and output operations. They're there to for the users to communicate with the computer, like for example, Windows. Error handling is also handled by the operating system, loading and running of programs, managing of security. So we'll talk about that also. And utility programs, remember the definition. It's the program that is needed, that is designed to carry out specific tasks on a computer. Now, essentially, they are programs that help to manage, maintain, and control computer resources. And what are the examples? Anti-spyware, antivirus, backing up files, disk repair and analysis, file management and compression utilities. All these are examples of your utility programs. So now let's move on to the you can say the description of these utility programs. Now, as we talked about, they are there to make your work a little easier. They are there to perform one simple activity. By the way, we all know what is a virus checker, antivirus. Yes, exactly. It's a program that is needed to remove viruses from the computer. And how the viruses can enter, I hope that we all know. It can enter if you are downloading the stuff from the untrusted sources. It can even come through internet. Maybe some websites have viruses without your knowledge. They are downloaded on your computer. The viruses can spread even through infected storage media also. So there are different reasons, and we should be very cautious whenever we are working on internet, that do not open from any untrusted source. Always open the files that are coming from the trusted sources. Now, what will antivirus do? They are going to check the file, or they'll check software before they are running on the computer system. And what does it do actually? How is it performing this activity? Although we have talked about it in chapter number 5, but let's very quickly recap. It's here also. How it performs this activity. Actually, antivirus has a database, and this database contains a list of all the known viruses. So what it does is, if it finds a virus, it checks that in its database, is it a virus? Is it a virus? Is it a virus? Is it a virus? If it sees it's a virus, it will actually say, fine, now this is a virus, so do some activity on it, do some action on it. And this is what is called heuristic checking. You can see it's the checking of software for types of behavior that could indicate a possible virus. And it is needed because maybe you are considering something to be a virus. So that is what the antivirus program will do. And in case it finds that something is infected, might be infected, it will be put into the quarantine. And what will happen when a file is quarantined? Maybe the file will be automatically deleted. Maybe the virus allows the virus to be automatically deleted also. Or in case it may allow the user to make the decision, maybe a file that is quarantined, a user, the actual person who is using the computer, may see the file, and maybe he can decide that whether the file has a virus, or maybe the file is not having a virus. Maybe the software has found something to be infected, but it is not. And that is what is called false positive. And that is one of the drawbacks. Maybe antivirus figured out some malicious activity and it thought that file to be containing the virus. So it will quarantine that file. But in reality, the file does not have any sort of virus. Then definitely the user, the person who is using the computer will be there to decide that whether it has a virus or not. What should be done with that file then? And remember, the antivirus software needs to be updated for the reason because new viruses keep on coming. And if it's not updated, then it will not be able to detect any new viruses that are coming. So that is why full check is needed at least once a week just to ensure that your system is not infected by any sort of virus attack. I hope that is very much clear. A very quick revision. Now, defragmentation, or you can say fragmentation. Actually, since we have talked about fragmentation in chapter number 3, if you remember, we talked about one of the drawbacks of HDDs were the files were fragmented. So defragmentation is actually doing what? You can see with the help of this diagram. I hope that this diagram is going to make the concept a little clearer. This is your like hard disk drive composed of tracks and sectors. Yes, definitely plateaus also. Now just remember, if for example I talk about this situation, till now file 1 is occupying sectors in this manner, and file 2 is occupying this much location, and file 3 is occupying this much location. In case we are working on file 1 once again, it may happen that file 1 may not occupy contiguous blocks, may not occupy consecutive blocks. Now the file is broken into pieces. And definitely remember, a file that is not present altogether may result in more time being taken to extract the file. And that is what is called fragmentation. So if we want that file should be stored continuously in contiguous locations, what we do is we use the utility program of disk defragmenter, and what its job is, will rearrange the blocks of data to store files in contiguous sectors as much as possible. So now after the defragmentation process has taken place, you can see for yourself that earlier file 1 that was spread over 2 locations, like 2 separate areas. This is I'm considering this to be first area and this to be second area. In this case, that file that was broken into pieces is now grouped together. You can see 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5.5. Now it's all together, it's present all together. So that is what the job of disk defragmenter is. I hope that is very much clear. No problem. Yes, exactly. Since we have performed this earlier, so I guess you can recall that it results in fewer read-write head operations. It will, and definitely that means your work will be accessed faster. Your data will be, you can say, stored in contiguous locations. So definitely that will be resulting in making your hard drive also perform a little better. So I hope that it's very much easier, isn't it, to comprehend? Now backup. What is backup? Why do we need backups, by the way? Exactly, that's wonderful. We need backups so that in case the original is lost, we can get the data from our backup location. Now, where do we store the backups normally? You're going to use maybe a memory stick for the purpose, or maybe portable hard drive. The main files, the main storage is on your hard drive, and we are using memory stick or portable hard drive, and definitely the optical media also for the purpose of storage, for the purpose of backup data. By the way, why do we use backup utility? You can see it. What is the purpose? It will allow a schedule for backing up data like backing up data at regular intervals. And in some situations, it only allows the backup to be taken in case some changes have taken place. And by the way, for security of the file, what we normally prefer is we need to have 3 versions of a file. The first one is the one that we are currently working on, that is maintained on the internal hard drive or SSDs. Second one is a locally backed up copy in the file. And the third one is a remote backup. And why are we storing the backup? Because we are going to restore the data. And we need to have a restore point that from where the restoration of the data will take place. So simple, what you need to know is the purpose of your backup utility. Why is backup needed? And how many versions of the file can you create? So this knowledge should be there with you in order to answer a question if it comes in the paper. Now, moving on to security software, the next one. It's an overarching utility that is needed to manage access control and user accounts. It is also linking to other utility software such as virus checkers. It is going to protect network interfaces, for example, through the use of firewalls. It is allowing the encryption and decryption to take place also, so that it is so that to ensure that any intercepted data is meaningless. It oversees the updating of software, and I hope that it's very much easy for us to comprehend the concept of security. Why do we keep this? Why do we need the security software to make our data secure from unauthorized access, from hackers? And I hope that's very much simple, isn't it? Now, the next one is screensavers. By the way, why are screensavers needed? And what is the advantage? You can see, but these screensavers were originally developed to protect the older CRT, the cathode ray tube monitors. And these CRTs were suffering from phosphorus burns. If the same image was present, then they were suffering from some sort of damages. Now, with the modern LCDs and LED or OLED screens, this is not the problem anymore. But still, they are there just to help you out in case you are moving away from your computer, you are leaving the computer for some time, and you don't want it to be unattended as such. So what you do is you may activate the screensaver so that it's still active. Some background tasks are taking place, and it's not visible to the user. So the screensavers will be there on the screen, and something may be happening at the background also. So that is also possible. Yes, very rightly quoted by Ali, that sometimes we do have screensavers on our mobile phones also. Although we rarely use them actually, but still at least we may have seen the screensavers available on the mobile phones also. Fine. So actually, they are actually there to activate use of background task to be activated. So it can go on when the computer is active, when the computer is actually active doing some work, but it is not showing anything on the screen. Like maybe for virus scanning that is being performed, maybe if the data is too much, then virus checking is being done, virus scanning is being done, and the screensaver is actually on the screen depicting some activity to be taking place. Device drivers we have just talked about, so I hope that there is no need to rediscuss this. You all have understood this thing. But one thing that I want you to understand and remember, maybe some terminologies may come in the paper. So all USB device drivers contain a collection of information about devices, and this is given the name descriptors. So just be cautious about the terminology that can come in the paper, and you should be able to answer that. Now, any questions before we proceed to the next topic of operating system? Just now we have talked about operating system like you talked about operating system like Microsoft Windows, Apple Mac OS. You can talk about Android. You can talk about Apple iOS. Yes, these are the Apple iOS and Android are basically for the smartphones and the tablets. And talking about the other, we have heard about the Unix also and Linux also, and we have heard about DOS, although it's not in use anymore. But these all are examples of operating system. What are the operating system doing? What are the functions? Now, let's very quickly see this whole discussion, and then we'll proceed to the explanation of each and every operating system task separately. Each and every single operating system functions separately. HCI, multitasking, platform for running of application software, management of user accounts, managing files, hardware peripheral management, which includes the device drivers also, memory management, interrupt handling routines, security, which is there to manage the logon and the passwords. So these all are the features or the functions performed by the operating system. Now start from the beginning, HCI. What comes to our mind when you hear the term interface? Linking, actually, link created between the user and the computer. And the two types of interface that are very important are command line interface and graphical user interface. Although there are others also, but the most commonly heard and used interfaces are GUI and CLIs. What is the difference between the two? When you type the commands, that is CLI. Like definitely, that's very accurately said by Emma, that definitely you need to memorize the commands. Even a single mistake for full stop or a dot or maybe a colon sign that was required there, if you have missed out that colon sign, you have missed out a dot that was needed there. So the command line interface will never function the way it is you desire. On the contrary, GUIs make use of WIMP, and these WIMP or Windows icons menu upon devices are going to make your life very easy. And remember, this window is really small, and because of the way it opens in a separate window. Now, if I talk about the main differences, and like we've talked about, CLI is typing the commands to get the task done, while GUI is clicking on different icons to get the task done. And definitely, every single application opens in a separate window, as you can see. Like, for example, right now I have opened this book. If I try to open maybe Word or maybe Excel or PowerPoint or any other application, then that will be opened in a separate window. So that is what is the idea behind window. Icons are small, you can say this, the graphical representation of a file, a folder, or an application. And point devices, like we need the mouse. But basically, the thing that comes to our mind is the mouse. Although we have other point devices also, but remember, pointing devices are always working with GUIs. They were not designed to be used with CLIs at all. Because here, in CLI, the user is direct communication with the computer, and he needs to learn the commands basically. Now, this is your example of GUI, which you already know. And this is what I suggest you, that you need to actually figure out this, remember this advantages and disadvantages of both CLI and GUI. So very quickly recap, what is CLI doing? The user is in direct communication with the computer. The user is not restricted to a number of predetermined options. Like you can do a lot of things on your own also. You can actually make a lot of combinations of different tasks also. They're like, for example, a lot of commands we can join, like for example, different options of CLI commands we can use to get the required task. It's possible to alter computer configuration settings, a very important feature. It uses a small amount of computer memory. Like the biggest advantage of CLI is it's using lesser memory. It needs lesser memory. On the contrary, what the disadvantages are, user needs to memorize the commands. If you have made a small mistake, then the work will never be done for you. And definitely we need to learn the commands. That takes time also to learn. So it's not easy for the humans to work on CLIs. Each command must be typed in using the correct format, spelling, and everything should be followed. Like even the grammar, you are going to use the correct use of the full stops and the colons, and this is what I talked about right now. You have not written it properly, the work in CLI will not be done for you. On the contrary, GUIs, the user doesn't need to learn any command at all. It's user-friendly. A pointing device such as a mouse is being used to click on an icon, and we may use touch screens also, and we do have other devices also that are pointing devices, and they all are used with GUIs. Talking about the disadvantages, this type of interface uses up considerably more memory than a CLI interface. It's limited to the icons provided on the screen. Like you have to restrict yourself to the icons available. If icon is not there, then maybe something that people may not even know how to do the work. And it needs an operating system such as Windows to operate, which uses a itself, it is using going to use some memory of its own also. Now, I hope that it's very much simple. Remember this and you'll be through, inshallah. Memory management. Now, just think, we have one RAM and so many applications are opened. Yes, exactly. Very correct. That we have talked about we have talked about the virtual memory also. But in reality, the actual memory is your RAM, isn't it? If so many applications are open, then definitely some mechanism is going to be there to manage each and every application that is going to be given a certain space. And this is what is called memory management. So you can see the actual task performed by the operating system is regarding memory is to see that every single application is getting enough space in the memory, and no two applications are ever going to use the same memory, because that may result in some sort of conflict and the data will be lost also. And definitely your applications will not be producing the desired result. And exactly, security issues can also happen. So this is what is going to be the main task performed by the operating system, that every single application open in the memory is able to handle its data accurately. Nothing goes wrong with its data. It doesn't, can say the data will, does not move from one memory area to another. It should be present in its own area. And in extreme cases, in some worst case scenarios, your system may crash also. Like definitely that may happen, correct? Okay. Now, security management. What is security? I hope that we all know why do we need security of the data. Definitely so that we can ensure that only the data is accessed by the authorized person. So you can see it's there to ensure the integrity, confidentiality, and availability of data. It should not be actually opened and accessed by everyone. Only the person who has the ID and the password, or and who has different access rights, will be allowed to access certain parts of your system. And definitely, you need to be very much cautious about that. This is not violated. A person who is logging in and logging off, maybe in some security management software, can even note down that at what time the person logged in and at what time the person logged off. Maybe if he has logged on at infinite time interval, then that can also be seen and observed by the security management software. So it has a lot of tasks, and you can see for yourself that is there to help you out with the security of your data. Fine. Now, another thing is hardware peripheral management. Now, what is it actually? It involves all input and output peripheral devices, and it's there to communicate with all input and output devices. Definitely device drivers. Without the device driver, it's completely impossible. It ensures each hardware component is giving a certain priority, and they are able to make use of the buffers in case, like for example, in case of printers, we do have buffers that are there to store the data properly in case the computer is like its computer data is sent to the buffer, and from the buffer, the printer is able to get all the data, and then actually the computer is now free to carry on its task. So this all is managed again by the operating system. That is the queue properly maintained? Are the buffers handling the data properly? So all these are again handled by the operating system. Fine. No, exactly. Like you just need to very quickly go through this role of the printer management. We have been talking about it quite often. So you can see for yourself. I'm giving you 2 minutes to very quickly go through this. A question, then you may ask. Right? By the way, isn't it something similar to what we have been discussing quite frequently under the different headings, talking about the printer buffers? We have talked about it earlier also in chapter number 3. So just remember the same concept is going to be discussed somewhere else also, but the things remain same. Now, file management. What is file actually? You know, and file naming conventions, like for example, file name dot extension, and extensions are what basically? Like looking at the extension, you can determine the nature of the file. Like for example, docx determines, tells you it's a Word file. XLS is the extension for, XLSX is the extension for Excel files. TXT is the extension of text files. Then DBF is your database file. HTM, which you already have worked on as HTML files, and then BAT is your batch files. So we do have different files, and they are like file name you give, and the extension is given by the program. Like you create a file in Notepad, by default it gives the extension .txt. So they are just there just to tell that which software was used in order to make that file. Apart from this, what else is the file management is performing specific tasks like creation of the file, opening of the file, closing of the file, deletion or renaming of the file, copying and moving of the file. So they all are file management tasks. Similarly, maintaining the directory structures. What is directory? Yes, exactly. Thank you very much for raising this question. Actually, here we call it folders. So directory or folder are the alternate words. In our DOS environment, we used to use the word directory. Here in our Windows environment, we use the term folders for that, for the same. Ensuring access control mechanisms are maintained. For example, access rights are given to the files. Password protection is given there so that it is only allowing the person to have who has the password to open or work on the file. And it may become and the files may become available to only the authorized users. And in some situations, we do lock the files also, or maybe may lock the parts of the file also. Maybe some file parts are not visible to anyone. So this all is actually the file management task. And similarly, ensuring memory allocation for a file by reading it from the hard drive and loading it into the memory. This is again a file management task. So once you are trying to click on open and you open a file, so it means at that time is the file management utility that is coming in action to perform this task for you. Understood? Easy? Now interrupts, we will discuss it inshallah. Now platform for running our application software is also going to be discussed in multitasking. By the way, multitasking is simple. It allows the computer to carry out more than one task at the same time. And remember, it's like, aren't you using the term multitasking in real life also? Performing more than one task, like for example, you are listening to the music and you are doing the work, isn't it? And you are listening to my explanation, you are noting down, that's also multitasking, when we can call it multitasking. You are maybe talking to your friend as well as maybe you are doing some other work also, that is also multitasking. So remember what happens, how is it being handled? It's actually happening because the resources are allocated. Remember the memory management, the time frame that is allowed or given to each task is handled. So that every single task gets this impression is actually getting equal time of the CPU. So that no two programs are ever going to clash with each other. No two programs are ever going to have a problem with each other. They are all handled separately and they all are given a particular time frame and they are able to manage things in a proper fashion. And remember the definitely priority is definitely there and definitely they make use of your virtual memory also in some situations. Management of user accounts is, you can see, maybe more than one user allowed to go on into the system. And definitely in that case, the user's area is going to be separate so that no two users are able to access each other's data. Like, for example, if I have logged on to the PC and maybe some other time, some other person who is also an employee of the organization is logging in. So our data is supposed to be separate, and this is all done through management of user accounts. So that no two persons, and definitely this all is handled by the administrator. Administrator is there who is looking after all the affairs so that no two people are ever using or misusing anyone else's location, anyone else's environment. And this is all possible in a multi-user environment. Now, running the applications. We are going to discuss it here. A few more terms which I really want you to concentrate on is the term first, one is booting up. Simple. When you have turned on the computer system, the very first thing is operating system part of the operating system is going to be loaded from your hard drive into the RAM. And this process is given the name booting up. And here you can see the use of bootstrap loader is also there. And the startup of the motherboard is handled by the basic input output system. So I really want you people to consider a few terms. Booting up, the process where the operating system is loaded into the RAM. And then another word for it is the bootstrap loader. And then the third term is BIOS, and that is referred to as, like in short, it's basic input output system, and it's often referred to as firmware. And what is firmware? It's a program that is needed, that is there to provide low level control for devices. So these are certain definitions which I really want you to understand and remember. When it comes in the paper, you are able to answer that. How it's handled? The BIOS program is stored in a special type of ROM. And what is that ROM? It is called EEPROM, or electrically erasable programmable read-only memory. And what is EEPROM? It's a flash memory, and means its contents remain even when the computer is powered off. Now, it also means the BIOS can be written, rewritten, updated, or even deleted by a user. Now, remember, the BIOS components can be rewritten, can be updated also. Fine. Now, the BIOS settings are stored on CMOS chips. It's a complementary metal oxide semiconductor. It's powered up at all time by a rechargeable battery, and this CMOS battery is actually handled by the this CMOS is powered up all the time, and this is done through a battery, and this battery is present on the motherboard. And in case this battery is not performing well, then you need to go for some amendments. Some settings are supposed to be handled every time the computer is turned on, and we simply change the battery, and the system becomes starts behaving normally. Now, moving on to the term interrupt. What is it? It's a signal. Who sends it? A device or software. To whom? To the processor. Why it's sent? In two situations. First, it has finished some task, or it has developed some problem. So if the device has encountered a problem, then it raises the interrupt. If the software has encountered some problem, it will raise the interrupt. If either the device or software is able to complete the task, again, that will raise an interrupt. So you can see a few examples are mentioned below, like maybe the printer paper jam, or maybe the printer out of paper, or maybe there is some problem with your toner, or maybe some if you are using your inkjet printers, then maybe some problem with your nozzles, maybe some problem with your cartridges. So they are handled by interrupt. Interrupt will be sent from the devices to the processor, indicating some problem has occurred, and it needs the immediate attention of the processor. And in some cases, if some task is accomplished, then also the interrupt is raised. Now, one more important thing is, in some situation, the interrupt is going to be immediately processed by the processor. And it is all because of the interrupt priority. In some situations, the interrupt is serviced immediately. In other situations, it can be serviced at a later time. It all depends upon the priority. And there are two terms, like I hope that we are very much clear about this. And it allows, what is the advantage of interrupts? Actually, interrupts allow the computers to carry out many tasks, or to have several windows open at the same time. And you can see the way I talked about you people. Similarly, for a computer, you're downloading something from the internet, and at the same time, you're playing the music, and on the other hand, you are working on some file. So these all are handled by the interrupt, and these all functions are going to perform efficiently because of the presence of the interrupt, which is there to help the different devices operate efficiently. Any questions? That's exactly the topic of interrupt. It's very important. Along with that, what else you need to know is, whenever an interrupt is received, it needs to be serviced. And for example, if you're working on some task, an interrupt has occurred. So the status of the current task being handled is going to be seen somewhere. And what will happen? The contents of program counter and other registers are going to be there. They are going to be saved. ISR, or interrupt service routine, is executed by loading the start address into the program counter. Once the interrupt has been fully served, the status of the interrupted task is reinstated. Contents of all saved registers are then retrieved, and the process continues. Very simple. I've just read it for you people, but otherwise, very simple. Assume that you were doing some activity and interrupt has occurred. It means the current task that you're working on will be stopped. Definitely, the required registers will come into action, like VC and other registers that we have talked about. They will come into action, and it will be the interrupt service routine will definitely be activated. It will be storing the location of the current task. And the moment you are finished by servicing the interrupt, then you are going to start from the same point where it had stopped. And that is what is handled by ISR, interrupt service routine. it will be able to store from where the task was done, was actually the last point of the task, and will start from the same point and carry further. So this is something that you need to know. A question regarding interrupt can come in the paper. So this is a very important topic that you need to remember. Simple, not difficult. We have talked about buffers, we have talked about interrupts. Now, moving on to the next topic. We are doing just very quick recap of the entire syllabus. Definitely, we have done these activities in the class. If you have not done it, please do them, and they are very important as far as examination. Like this, from an examination point of view, you can get such questions in the paper. Let's move on to the next topic, 4.2, types of programming languages, translators, and your IDEs. We have talked about the term source code and object code in the beginning. We have talked about the translators like compilers. Now let's see. This is just a sample program. As you can see, Scratch, written in Scratch. And this is also a program basically. And what is a computer program? What you write, there is some instructions that are written to enable a computer to perform a specific task is called a program. Remember, a program can be written in high-level language or it's written in low-level language. What is the difference? Now, very simple. A high-level language is understood easily by the humans as it's closer to English. It's written in a shorter time. It's debugged also easily. It is maintained once in use. And along with that, you can see it's also not machine dependent. Designed for one architecture can work on other architectures also. Now, just for you to comprehend, this is a simple statement written in high level language. As you can see, sum equals to sum equals to first number plus second number. Now, if you talk about this, so this is what you already know. I mean, we are using any language like Visual Basic or Python or Cobol or any language that we talk about. They all are high-level languages. And here, the work is easier for humans, but it's a little time-consuming for a computer to work on. Now, remember, on the contrary, the same program, which is going to be written in a low-level language, will be a little more, you can say, time-consuming to write, a little more, not very much. And you can see for yourself, they are actually related to the specific architecture and hardware of a particular type of computer. They are sometimes referred to as machine code also, and assembly language. Basically, assembly language is your low-level language. And still remember that assembly language programs are also composed of instructions which need to be translated. A computer never understands assembly language instructions directly. Here, the role of an assembler will be discussed so that you can remember that this again is needing the translation. Fine. Now let's move on to a very quick recap of the definition we have talked about. Now the differences between high level and low level. Now high level, independent of the type of computer being used, the way I talked about right now, easy to read, write, and understand programs, quicker to write programs. Programs are easier and quicker to debug, easy to maintain the programs once in use. These are the advantages of your high-level languages. On the contrary, the disadvantages are programs can be larger, programs can take longer to execute, programs may not be able to make use of special hardware. On the contrary, low-level languages, they can make use of special hardware. They include special machine-dependent instructions, can write code that doesn't take up much space in the primary memory, can write code that performs the task very quickly. Now remember, programs written in high-level language are going to take longer to execute as compared to the same program that is written in a low-level language. Now, but for a computer, it's going to be executed a little faster. It's able to understand a little faster if the program is written in low-level language. Disadvantages of low-level: takes a longer time to write and debug programs. Programs are more difficult to understand. Now, telling you truthfully, a one line for this sum needs maybe 3 to 4 lines to perform the same task in your assembly language. So just to make you comprehend, this is not an easy thing to learn, but inshallah, you will be learning it in your later years. The assembly language is also a part of the syllabus, inshallah, in the future. Now, you can see, just to make you remember, LDD, LDA, LDX, add, STO, there are a lot of commands that are there. and they all are actually low-level language instructions. So you don't have to again rote learn them at all, but you can see for yourself something that is not similar to English means it is a low-level language program, right? Now translators, the way we talked about translators, compiler we have talked about already, interpreters we'll talk about, and assemblers also we talk about. So compiler is going to translate the whole program written in high-level language to machine language in one go, and it generates a list of errors. While on the contrary, interpreter is a line-by-line translator. It takes one statement at a time, translates it and executes it, and then moves on to the new line. Then picks up the second line, translates it, executes it. In this manner, it is going to perform the same activity of moving to the line, taking it, translating it, and executing it until the program is finished. And remember, a program is needed to be translated every time, interpreted every time when you are running the program. On the contrary, with compiler, programs compiled once can be used as many times as you need to without the need of the compiler at all, without the need of the source code at all, because that is exe file, executable file that can run without the source code that can run without the compiler. On the contrary, like assemblers we have talked about a little bit, assembler is a translator that is needed to translate a program written in low-level language or assembly language into machine code. Please remember, it translates a program written in low-level language, not if someone says it is there to translate low-level language, that will be completely wrong. You need to mention programs written in low-level language, programs written in high-level language to get marks. And remember, the programs that are written in high-level language or low-level language, after being translated, will be understood by the computer. Fine? Now, very quickly, going through this compiler, interpreter, and assembler, you can see for yourself, compilers and interpreters, they have something in common. Like it translates a high-level language program to machine code. Similarly, same goes for interpreter. On the contrary, an exe file is produced in high level in compiled programs, while no exe file is produced in your interpreted program. One high level language statement can be translated into several machine code instructions. Same is applicable for interpreter also. If you write down one command in high level language, whether you are using a compiler or an interpreter, they both will be translating that one command into a series of stages, into a series of steps. On the contrary, if I talk about assembler or assembly language programs, one instruction is equal to one machine code instruction. So when you write down the program in assembly language, one equals to one. On the contrary, in compiler or interpreter, one statement may be composed of several machine code instructions. Okay? A compiled program is usually distributed for general use, like you talked about. Any program that we are using, they all are available as in the compiled form. While an interpreter is often used when you are developing the program. Because when you are running the program, you're finding out the errors, finds perfectly okay. Find out the errors, correct them, and then move ahead. On the contrary, when we talk about the compiled programs, the whole program generated as the object code may show you a list of errors, and sometimes the people may get overwhelmed. And that is why normally the people prefer to use interpreter in the beginning, and once they are through with their whole process of translation, they are okay with their work, then they compile it in the end. Okay. Now let's move on to assembler. We have talked about translators. It translates a low-level language program into machine code. Again, the word program, very important. Exe file is produced. The same thing as I talked about right now. One language statement is equal to one machine code instruction. Assembly programs are used without the assembler. The same thing as we talked about the compilers. An assemble program is usually distributed for general use. By the way, just asking, a question can come in the paper that write one similarity between compilers and interpreters. So what will you write? Exactly, that's wonderful. They both are there to translate a high-level language program into machine code. By the way, is this the only similarity, or is there any other one? Another one, the third one, that's correct. So it means I can simply say, if I talk about the similarities, I can simply say what? Okay, now just to make you understand what are we doing, if I just say this one and this one is the similarity between your compiler and interpreter. Fine, they both are similar. Now, on the contrary, if I say these are your differences, this is a difference, and this is a difference, and this is a difference. So in this manner, you actually have discussed this thing that in order to remember the points, compilers and interpreters, the differences and the similarities, you can get a question like this very easily in the paper. On the contrary, if I just talk about this one, for example, if I say the similarity and the difference between compilers and assemblers, you can see this one is actually a difference between a compiler and an assembler. Definitely, that's very much visible. But if I talk about this one and this one, this is actually a similarity between a compiler and an assembler. They both are creating executable file. Similarly, you can see they can run without the compiler. Assembly programs can run without the assembler. This is also a similarity. And another one, as you can see, this is also a similarity. Here you can see these all three are the similarities between the compilers and the assemblers. On the contrary, you can see a lot of differences. Two differences are also there. It's easy to comprehend, not difficult. So question can come in the paper, talking about the similarities and differences between the different translators. So you are prepared, you can answer. Understood? Yes? Okay, wonderful. Now, interpreter and compiler advantages and disadvantages, the same as we have been talking about. You can go through this very quickly. If you have a query, then you can ask me. Just 2 minutes, very quick reading. It's actually in a compiled form, the same thing as we have been discussing, but still, let's very quickly go through this. Any questions? Okay, none, that's wonderful. Now, the last simple topic of this chapter, IDEs or integrated development environments. What is it actually? It's basically used by the programmers to help in writing and developing the programs. And you can see this is basically there just to help you the same location, the same environment, which is available for typing the programs, finding out the errors in the programs, running the programs, the same, and everything is available at the same location. Like you can see, we have heard about PyCharm that is available for Python. We have used Visual Studio for Visual Basic, like maybe for Java also. There are different IDEs that are available, and they are giving us these simple features. So I'm just very quickly recapping this topic we have discussed earlier. What you need to know is you need to know the ID features, the main ID features. The first is code editor, a translator, a runtime environment with a debugger, error diagnostics, auto completion, auto correction, and auto documenter and pretty printing. Now, detail is already present. You can go through if you really want to, but for the time being, what you need to know is you need to know the features of the IDE. If you have actually remembered the few features like pretty printing, autocorrection, like you may have seen, once you start typing something, it sometimes prompts you also, helps you also, which you can choose the different variables or something like that in PyCharm. So that is basically all the feature, one of the features of IDE, integrated development environment. So they are discussed in detail earlier. I hope that you are clear with that, but still, this was just a very quick recap. I hope that you have understood each and everything which is discussed in the quick recap today. Jazakallah khair Kasira for being a part of the learning journey. Hope that you have understood everything that we have discussed. Take very good care of yourselves. Have confidence in yourself. Do your best and leave the rest on Allah. He is the best person. He is the best authority to decide your fate. Do not get worried. May Allah bless you all. Allah Hafiz. And do not forget to subscribe the channel, share with your friends and family so they all are going to benefit from it. Take very good care of yourselves. Allah Hafiz.